Hello, everyone. So, our next lesson that we're going to do this week is Lesson 12. So, in Lesson 12, we're looking at choosing appropriate scales for our coordinate plane. So, we're still dealing with the coordinate plane, but this time we're looking at taking and scaling it. So, sometimes having it start at 0, 0, it'll always start at 0, 0, don't look at me wrong, at our origin, which was our keyword last time. So, it's going to start at 0, 0, but sometimes instead of going from 0 to 1, maybe we'll go from 0 to 10 or 0 to a half. It kind of depends on what the information is that we're actually taking and trying to represent, what kind of scale we need to put on our graph to make it make the most sense and to make it visually look the most readable. So sometimes if we have a kind of odd scale for a certain set of data, sometimes we can't really get much information from it because if it's, if we're going up by tens and we have a half, a quarter, and, 3/8, that's all going to be right close together when really it's a little more spread out. So keeping that in mind, we want to have these scales make the most sense for the data that we have. So looking at this, our first part of what we're looking at today here is English winter. So the following data were collected over one December afternoon in England. So we've got the time, afternoon in hours. So at noon, it was 5 degrees Celsius. At 1, it was 3. At 2, it was 4. 3, it was 2. 4, so on and so forth. So we've got these different temperatures in Celsius and the times after noon. So 0 being noon and so on and so forth. So what we want to take and determine is which set of axes would you choose to represent these data. So we've got this first one here, A, then we have B, and C is on the next page, so I will scroll that down so you can see it. So we've got C here. It looks like it's going up by tens each time. And let's see. So both the X and Y axis are going up by 10 on C. On B, it looks like we're going up by 1 on the X axis and 1 on the Y axis. And for A, now A looks a little different, is my guess, is what you're thinking first and foremost. A is just the first quadrant. So we've got our origin here. So what do we know about the first quadrant? It's only positive values. So all of these are going to be positive values. So looking at our data, which of these makes sense? Well, should we do A? No. Look at this. We've got all these, give me one sec. We've got all these negative numbers. Those 4 data points would not be in A. So A is not the best option. So what about B? Is B the best option? Can we do our positive values? Yeah, we definitely have the positive values. Can we do the negative values? They are taken care of this time. Will this one work fairly easily for us? Yes, B will work pretty easily. Let's take a look at C though, just to double check. So looking at C, we've got the negative. Clearly, we have the positive. So we've got both the negative and positive here. But do we have 10 hours after noon? No, we don't. So in this graph down here, all of our points, not even just our first point, but all of our points are going to be right in here. They're going to be all the way up before 10. Somewhere right in this first little bitty tiny box is where all our values are going to be. Is that going to be very easy to read and understand that data? Probably not. It's scaled not very nicely for us. It's all out of whack for what we're taking and dealing with. So B is the best option here. Now, reason being that B is the best option, I have it wrote down so you can see it rather than me trying to write on there. So let me make this bigger. There we go. So option B represents represents the data the best because all the data points will fit on the graph nicely where the grid lines meet. So not just the fact that it's going to take and include all of our points, but it's also going to make it so we don't have to figure out, okay, where's exactly in between here, and trying to figure out partial values is very complicated to get an exact amount. So we want to have it so it can line up on grid lines if at all possible. So keep that in mind as we go about this. All right, so for part 2, of that question. Explain why the other two sets of data did not seem as appropriate as the one you chose. Well, as we were taking and choosing these, we kind of went through that. For C, it was scaled by tens. Our first grid line was at 10. That's not beneficial to us. Our data doesn't go that high up, so it doesn't make sense to use that. This first one, like we said, it only has positive values, and so it won't take into account our negative values. So once again, I'm going to show you what I have wrote down just for those of you who do better at seeing what's wrote, and rather than me trying to write all of that with the pen, with the stylus, I should say. So we've got option A was not the most helpful because there's nowhere to plot the points with the negative coordinates. And option C is not the most helpful because the grid lines are spread 10 units apart, so it's hard to plot coordinates that are not multiples of 10. So none of our coordinates were multiples of 10. They were all less than 10 even. So all of our values would have been contained in that very first little box of our graph. Well, first box and the lower box as well of our graph. And that just wouldn't have been very beneficial for us to be able to understand what it actually looks like and what this data is, because there's a pretty wide spread on our data for this. We're going all the way from positive values to negative values. I mean, we have a high of 5 and we're going down as low as -4. That's quite a big spread of temperature. And if we were to look at it on this C graph down here, we would barely notice that change because of how this is scaled. So be careful with scaling. So your guys' keyword, my goodness, I apologize, for this lesson is scales. So being as you're going to be doing a lot of scaling and determining what scale you should use on your coordinate plane, scale is going to take and be our key word for this lesson. So scales or scale, either one will be perfectly acceptable for your keyword submission. All right? Okay, so let's practice some with taking and deciding on different scales. So what we're looking at here is we're going to draw the axes. So the axes are our X and Y grid lines. We call them axes in the coordinate plane. So we have 3 sets of coordinates. For each set, we want to draw and label an appropriate pair of axes and then plot the points. So we're going to have the axes drawn. So in previous problems, we've always had those axes. Now we have to do it ourselves. And then we're going to plot these points out. So let me make my pen a little smaller. Oh, let's do this one. Okay, so if we look at our data, we've got the point 1, 2, the point 3, -4, the point -5, -2, and the point 0, 2.5. So if we think about the set of data that we have, it's fairly close together. We're just going up for the most part within ones. We're not jumping very far in our data. And we have both positives and negatives involved. So we need to have all 4 quadrants when we draw this out. So I'm just going to draw it right here. My blue line is a little bit off of the actual line on this graph. Try to get yours as close as possible when you do it. It's trying to figure out where my stylus writes is clearly a little bit off on this. But you want that to be a nice straight line right along that grid line. Now, for my x-axis, I'm just going to go right here. Looks like I did a little bit better this time. So this is my x-axis. This is my y-axis. So remember, y is always going to be the vertical. X is the horizontal. All right, so now we take and plot our points. So I'm going to use green for this and a little bit bigger scale. So we've got the point 1, 2. So we start at the origin. We go to the right 1 because X always comes first. And then we're going to go up 2. Then for 3, -4, we're going to go to the right 3. So starting from the origin, always go back to the origin when you plot points. Don't go from here over 3 and then down 4. That's going to be completely different. So always start from the origin. So over 1, 2, 3, and then down 1, 2, 3, Oh, pardon me. All right, the next one we're looking at is -5, -2. So we're going to start at the origin once again and go over 1, 2, 3, 4, 5, and then down our -2. And last but not least, so this one we have 0, 2.5. So because it's 0, that means we're not going to move off the y-axis. We're just going to go up 1, 2, and then part way between the 2 and the 3 to get our 2.5. Now, I took and plotted all of these points without actually having what each of our grid lines or lines on this grid represented. So I'm going to include the scale now. So this is 1, this was 2. Oh my goodness, that's a little off. Hang on. This one is 1, this one is 2, this one is 3. It should be a 3. Doesn't want to write a 3. Then we'd have 4, and so forth. Then here we're going to have 1, then 2. This would be 3, and this would be 4. Should be a 4. Pen doesn't want to work quite right here. This will be -1, -2. Oh my goodness, why does that not want to write? Hang on 1 second. -1. This is -2. Then we have -3. And we could keep extending this out. We don't have to. As long as we have the first quadrant marked, the other quadrants are going to be the exact same. So it's not going to change within the coordinate grid. So as long as we have the top part of our y-axis and the right part of our x-axis labeled, then we know how it's going to be scaled. It's not going to be different to the other sides. So you can include all of the values as you go about doing it, but you are not required to, unless it asks you to fill out the entire set of axes with the scaling. All right, so here's one scaling for us. Now we're going to go ahead and take a look at this next one. So for B, we have the point 50, 50, 0, 0, -10, -30, and -35, 40. So once again, we have both positive and negative coordinates. So we need to have all 4 quadrants represented in this. But what else do we notice about our points? They're pretty spread out. We're going all the way from 0 to 50 and from 0 to -30 and -10. We've got points all over the place with this. So are we going to have to scale it pretty significantly? Yeah, we are. We definitely are. We don't want to have this too close together. We don't want to take and count out all the way to 50 by ones. That's going to be a huge graph, and we only have this little amount of space. So I'm going to take and draw my y-axis right here. Hopefully I can draw it nice and straight for you guys. Hey, not too bad. All right, so there is our y-axis. So remember, y is always the vertical. So this is our y. And then for my x-axis, I'm going to put that right here. X-axis is a little hard to draw for me, apparently. Try and keep it as straight as possible. Oops. Like I said, trying to draw with this is not the easiest. Okay, so we have our x and our y. Oops, sorry. X and our y-axis. Y is always the vertical. X is always the horizontal. And now we need to scale it. Scale being our key word for this lesson. So scale. All right, so looking at this, I'd say based on how far apart our coordinates are, going up by 10 would be a reasonable scaling for this. So there we've got 10, 20, 30, 40, and 50. And this will be the same. This will go 10, 20, 30, 40, and 50. All right, let me include some of those values. This is 10, 20, whoops. That was not a 20. I'll skip the 20. This will be 30, 40, and then 50. So I only wrote the odd numbers down just because space-wise, I don't have a lot of space to take and write between these. You can write all of them by all means, but I'm a little bit more limited space-wise for how I can write it. So then this will be 10, then there's 20, then we'll have our 30, 40, and then our 50. So same thing, I just skipped every other one, so skip the 2 even ones in writing the names down, but that does not mean that we skip the 20 and the 40 in terms of graphing this. So now we need to take and graph our points. So make this a little larger. So we've got the point 50, 50. So we're going to take and go start from the origin, and we're going to go to the right 50, and then we're going to go up 50. And there's our coordinate. Now, our next coordinate is 0, 0. 0, 0 is just the origin, so we don't have to go anywhere from our starting point. The next one we have is negative 10, negative 30. So start at the origin, go over to the left, negative 10, and then down, negative 30. And our point will be right there. And then for the last one, we have the point negative 35, negative 40. So once again, go back to the origin, go over 10, 20, 30. Now we are partway between. So we're going to go partway between. That'll get us about 35. And then it's a positive 40. So we're going to go up 10, 20, 30, 40. So our coordinate should be about right there. So obviously this was not perfect. If we would have done it by 5s, then every single one of our points would have been right on a grid line. Obviously, we didn't do that for this one, but that would have been another option. So sometimes there's multiple options for the exact same graph to still give a beneficial and accurate representation of the data. So going by 10s is fairly accurate. Going by 5s would be even more so. Things could be, all of them would be right on grid lines, whereas this one, we've got the one that's partway between. All right, we're going to look at one more of these scaling graphs. Now, what do you notice about these coordinates? Almost all of them are less than 1. So we've got a bunch of different fractions in here. We also have negatives in here, which means we're going to have both an x and a y axis. So I'll go ahead and draw those in. So get your y axis. Ooh. Trying to keep it as straight as possible. So there's our y-axis. So y. And then I'm going to put my x-axis right here. Let's see if I can keep this one straighter. Oops. Sort of. Okay. So we've got our x and we've got our y-axis. Remember, x is always horizontal. Y is always vertical. But now we need to figure out how to scale it. So once again, remember, scale is that key word. All right, so looking at this, we have 1/4 and 3/4, -5 and 1/2, -1 and 1/4, and -3/4, and 1/4 and -1/2. So what do we notice about all of these values, especially the denominators? Yeah, we can convert them all into fourths. So we've got the 1/4 and the 3/4. 1/2 is the same thing as 2/4. So we can go up by fourths on this. So our scale is going to be by 1/4. So keep that in mind. That means this right here is 1/4. This is 2/4. This is 3/4. Then we have 4/4 or a whole. And then there's the 5/4. Now I'm going to try to write these fractions in. I know it's going to be a little difficult because writing fractions very small. So like I said, this is 1/4. 2 fourths, 3 fourths, this is 4 fourths, 5 fourths. So it's a little rough, but like I said, that's why I put this scale here. We're going up by 1/4. So every single one of our lines is going to be a new fourth. So there we've got 1/4, then we've got 2 fourths, then we've got 3 fourths, then 4 fourths, then 5 fourths. Okay, so when it comes to plotting these, we've got 1/4 and 3 fourths. So we'll start at our origin. We're going to go over the 1/4 and then up 1, 2, 3 fourths. So there's our first one. Our next point is -5 fourths and 1/2. So we're going to start at our origin and go left 5. So 1/4, 2 fourths, 3 fourths, 4 fourths, 5 fourths. And remember, we're going in negative direction, so these are all negative numbers. And then a 1/2. So 1/2 was same as 2 fourths. So there is our -5 fourths, positive 1/2. The next one is -1 and 1/4. Remember, we can take mixed numbers and convert them into improper fractions. So we take 4 times 1, which is 4, and then add 1 to it, which will get us 5. So this is going to be a -5 fourths and 3 fourths. So we start at our origin, we go over -5 fourths, which will put us right here, and then we're going to go down 3 fourths. So 1/4, 2 fourths, 3 fourths. And last but not least, we have 1/4 and -1/2. So we're going to start at 0, 0, the origin, and we're going to go over 1, and then we're going to go down 1, 2. Because remember, 1/2 is the same thing as 2 fourths. So in this case, a -2 fourths. So these are our points. So like I said, when it comes to scaling, it's all about what the data is. So if you've got fractions, you probably want to scale it by some fraction that works with all of them. So if you're dealing like with this one, we had a lot of fourths or numbers that could be wrote in terms of it being out of 4, because 2 can be multiplied by 2 to get us to 4. So 2 is a factor of 4. So being as that was the case, going up by fourths made the most sense. If we would have had fifths in there or sixths or things like that, we would have wanted to try and make it so that it makes sense the numbers we're going up by, so we don't have to figure out partway betweens. We want it to work out nicely, especially when we're dealing with fractions as is. We don't want to have to go partway between when we're dealing with a fraction. That's just not going to be a fun thing to do. So what you're going to be looking at through this lesson is taking and determining what is an appropriate scale for a given set of data, and taking and graphing points out using different scales that you come up with to take and best represent the data. So there's a little room for interpretation on these in terms of what is best. Think about it like we talked at the very beginning. Can we see all of the data points? Is it easy to see all of the data points, or is it too large of numbers for what we're going up by each time, so what our starting values are. So keep that in mind as you take and do this. A final reminder, our key word for this lesson was scale or scales. Either one is perfectly acceptable. That's all. Make sure you get that submitted on Canvas, and you guys are doing awesome. Good luck.